Now that we've defined our terms, let's talk about chemical bonds and chemical reactions. So our learning objectives here are to explain the role of electrons in chemical bonds, to talk about some different types of bonds, and to compare some basic chemical reactions. So chemical bonds are all about the electrons. Electrons live in those shells that we talked about, and only the outer shell is going to interact with a nearby atom. So when two atoms get near each other, it's their outer electron shells that are going to meet and interact first. And atoms, they're striving to fill their outer shell. So their outer shell, for most atoms, can fit 8 electrons, not the small atoms, obviously, but the larger atoms, they can fill up to 8 electrons. And their goal is to fill that outer shell to be happy. Okay, and they're going to react with other atoms until they feel fulfilled, until they have a complete and full outer shell. So inert atoms are happy by themselves. They have filled their outer shell. So helium is a small atom, right? So it only needs 2. But neon, it has those 8 electrons in that outer shell. It's got a full and complete valence shell. Whereas reactive things like carbons and sodiums and oxygens, they're missing electrons in their outer shell. So carbon only has 4 electrons. Oxygen only has 6 electrons in that outer shell. Sodium has 1 electron, right? So they're going to react until they fill that shell. And how they react determines the type of bond that's formed. So in ionic bonds, the electrons are going to be completely transferred. So one atom is going to say, I have an extra electron, and it's going to interact with an atom that says, I really need just 1 electron. And they will transfer it. So it's like giving them the electron. Now, this creates 2 ions or charged atoms that are either negatively or positively charged. Negative, they took the extra electron. Positive, they gave it away. Shown here, sodium and chloride. Sodium is going to have that positive charge. Chlorine is going to have that negative charge. And now they're bonded together with that ionic bond. It creates a negatively charged anion and a positively charged cation. The way I remember this is I have a cat, and it's a positive thing in my life, so positively charged cation. If you don't like cats, it's not going to work for you, but I don't really have an alternative. So just think of that. Cats are positive, positively charged. Okay, so that's ionic bond, fully transferring the electron. Covalent bonds is when they're going to share those electrons to fill their outer shell. So hydrogen gas, for example, 2 hydrogen molecules, they need to each have 2 electrons. They're going to do a sharing is caring. They're going to get together and they're going to say, let's share these electrons together. Now, if they're equally shared, then that's a nonpolar molecule. So carbon dioxide, those 2 oxygen atoms and the carbon, they're all equally sharing the electrons together. That's nonpolar. However, if they're unequally sharing the electrons, that's a polar bond. So if someone gets greedy, for example, in water, oxygen has gotten greedy. It has taken more of the electrons, creating a partial negative charge near the oxygen and a partial positive charge near the hydrogens. This is called a polar bond. So again, we have ionic bonds, covalent bonds, and then we have 2 types of covalent bonds, nonpolar and polar. Polar molecules can also do something fun. So it's called hydrogen bonding. This is the weakest of the bonds that we've talked about so far. And this is where we have a hydrogen that's bound to one of those oxygens that has one of those partial positives, is attracted to the partial negative on an oxygen or a nitrogen. That attraction of negative to positive, right, opposites attract, but because it's only a partial charge, it's kind of a weak bond, hydrogen bonds. Okay, finally, let's talk about chemical reactions. Synthesis reactions make things. We're going to synthesize. We're going to take little pieces and make something big. Decomposition reactions are the opposite. We're going to take something big and break it down into its little pieces. So synthesis, make, decomposition, break, and exchange reactions, we're just going to move things around. So shown here, we're going to take a phosphate group off of ATP and throw it onto glucose. So synthesis, make, decomposition, break, exchange, move things around. And things that increase the rate of reactions are things like heating it up, increasing the temperature, increasing the concentration of the number of particles reacting, decreasing the particle size, or adding a catalyst, something like an enzyme. And we'll come back to enzymes and catalysts when we talk about proteins. So in this video, we talked about chemical bonds and chemical reactions. In our next video, we will talk about biochemistry.